All right, so this is a lectures question from M24 TZ2 T1 question 11. So it says the plane pi 1 has an equation 2x plus 6y minus 2z equals 5. And it wants us to verify that this point is on the plane. There's only one mark. It's pretty simple. We substitute the values of the point into the equation of the plane, and that's it. So we get 2, 2 plus 6, 1 by 2. Minus 2, 1 equals 4 plus 3 minus 2 equals 5. All right, that's it for that part. We have now a second plane given by k squared minus 6x plus 2k plus 3 plus pz equals q. And they say that these three are real numbers. They say that given that p equals minus 6 and p2 is perpendicular to p1, and A lies on P2, or pi2, sorry. They want us to find the value of K and Q. So the way we approach this is by considering the normal vectors of the planes. So for pi1, so we'll call it n1, this is a normal vector, and we'll say that it's equal to, actually do it like this, 2, 6, and minus 2, okay? And the second normal vector is equal to k squared minus 6, 2k plus 3, and e. And we know p is minus 6, so we can just write that. And it says that the planes are perpendicular, so that means that the normal vectors must also be perpendicular. Because say we have a plane here, and this is the normal vector, and we have another plane here, like this, which is perpendicular, and we have a normal vector here. You can see that the normal vectors themselves also form a right angle. So we can say that P2 is perpendicular to P1, or pi1, implies that n2 is going to be perpendicular to n1. We don't actually have to write this in the exam, but it's good practice. So now well, first of all, we know that if the angle between the vectors is going to be 90 degrees, we know the angle is given by cosine theta equals n dot, or a dot b over a times b. This is the simplified version. So, and cosine of 90 degrees is given by 0. And this is only the case of the dot product a and b is equal to 0. So we know that a dot b equals 0. Okay. So that means that n1 dot n2 must be equal to 0. And the way we compute the dot product is we multiply the individual elements or components, and then we just sum them together. So we get 2k squared minus 6 plus 6, 2k plus 3, minus 2 minus 6 equals 0. And this is going to give us quadratic equation. If we expand this, 2k squared plus 12k minus 12 plus 12 cancel, plus 18 equals 0, or k squared plus 6k plus 9 equals 0. And this is a perfect square, so it gives us k plus 3 squared equals 0, or k equals minus 3 only. So we found that k is equal to minus 3, and now they want us to find the value of p. Or no, sorry, q. So q is the constant term of this. All right. So that means that the equation of pi2 is going to be given by k squared minus 6x plus 2k plus 3 y plus z. Okay. And we know that k is equal to minus 3, so we substitute this in. So we get minus 3 squared is going to be 9. minus 6x plus 2 times minus 3 is minus 6 plus 3, y plus z equals q. So we get 3x minus 3y plus z equals q. And the final bit of information we get is that a lies on pi 2. So we substitute that in. So 3, 2 minus 3, 1 by 2, plus z, or plus 1, if I'm correct, equals q. And so we get 6 minus 3 over 2 plus 1 equals q. So q equals 7 minus 3 over 2, or which is equal to 11 over 2. That's it for part B. Uh, for part C, we're now given that pi 2 is parallel to pi 1. So this case does not apply anymore. With k equals 3. So we'll say that C, for part C, pi 2 is parallel to pi 1, k equals 3. Pi 1 is given by the equation 2x plus 6y minus 2z equals 5. Pi 2 must be given by, well, it's gonna, if k is 3, it's gonna be 3x plus 2 times 3 plus 3 is gonna be 9y plus pz, which is what they want us to find. They want us to find p. It's equal to q. Okay. And it's parallel, so the normal vectors must be the same. So we get that, because this, in the end, this q right here does not matter, because this is just an offset constant. So if you have plane here pi 1, plane here pi 2, they're parallel, but the q stays the same because it's just the offset factor. The normal vector is the same. So 2, 6 minus 2 is equal to, actually is going to be k, so some multiple of this right here, 2, 2, or 3, 9 p. And I believe we just find the, yeah. All right, so we get 2, 6 minus 2 equals 3k, 9k, and pk. And we'll just say, all right, 3k equals 2, k equals 1 by, or 3 by, 2 by 3. So we get that this right here, 3 times 2 by 3, 9 times 2 by 3, p times 2 by 3. This should be equal to p, or, sorry. Oh, okay, actually, never mind. Scratch this. So 3k equals 2, k equals 2 by 3, and we know that pk is equal to minus 2. So we get p times 2 over 3 equals minus 2. 2p equals minus 6, and, or, yeah, and p must be equal to minus 3. That's the solution part C. Now we get that q equals minus 51 over 2. So D, part D, q equals minus 51 over 2. And that the line A, line through A that is perpendicular to pi 1 meets pi 2 at point B. Okay, so now we have that there's a line that goes through pi 1 and point A, and it meets pi 2 at the point B. And we have this q value. So the way this works, we must find the vector equation of the line that passes through A and is perpendicular to pi 1. If it's perpendicular to a plane, that means the direction vector of the line must be equal to the normal vector of the plane. So we know that R is given by well, or sorry, we'll call it line L. R equals the position vector, so A, 1 by 2, 1, plus, and then we'll say some parameter lambda times the normal vector of the plane pi 1, so 2, 6, minus 2. Actually, we can also simplify this and say it's just 1, 3, minus 1, because it can be any multiple of lambda. All right, and it says that it meets pi 2 at the point B. All right. And we know that the equation for pi 2 is going to be given by 3x plus 9y minus 3z is equal to minus 51 over 2. 51 is divisible by 3, so we just get x plus 3y minus z is equal to minus 17 over 2, I believe, yeah. Or we'll say 2x plus 3 plus 6y minus 2z is equal to minus 17. Okay, that's that. And basically, it meets at the point B. So 2xb plus 6yb minus 2zb is equal to minus 17, because b must lie on that plane. We also have here that r is equal to, so this is equal to 2 plus lambda, 1 by 2 plus 3 lambda, and 1 minus lambda. This is the equation of the line. So if we visualize this, actually, we'll get like something like this. So this is the plane pi 2. This is the plane pi 1. This is A. This must be B. And A is at the coordinates 2, 1 by 2, 1. The line is like this. Okay. So the plan here is we substitute these coordinates into this equation right here. So we get that 2, 2 plus lambda, plus 6, 1 by 2 plus 3 lambda, minus 2, 1 minus lambda is equal to minus 17. So we get 4 plus 2 lambda plus 3 plus 18 lambda minus 2 plus 2 lambda is equal to minus 17. So we get 5 plus 20 plus 2, 22 lambda is equal to minus 17. So 22 lambda is equal to minus 22, and the numbers are working out nice, so we know it's probably right direction. So lambda equals minus 1. So we know that xb is going to be equal to 2 plus minus 1, 1 by 2, plus, or else the coordinates would be 1 plus 3 times minus 1, and 1 minus minus 1. And if you evaluate this, you get 1, 1 by 2 minus 3 is equal to minus 5 over 2, and 2. This is the coordinates of B. And hence, they want us to find the distance between the perpendicular distance between pi 1 and pi 2. And this is easy. We just use the distance formula because, as seen in this diagram right here, the perpendicular distance is going to be the distance between A and B. The coordinates of A are 2, a half, and 1, and this is the coordinates of B. So we just use the formula. Put DI here and then DII here. D is going to be equal to the root of 2 minus 1 squared plus 1 by 2 minus 5 minus 5 over 2 squared plus 1 minus 2 squared. So we're subtracting B from A. Yes, so this is going to be equal to the root of 1 plus 1 minus minus 5 over 2 is going to give 1 plus 5 over 2, or 1 over 2 plus 5 over 2, which is equal to 3 squared, which is 9, plus 1. And this right here is given as root 11. Now for part E, they want us to find the equation of a third parallel plane, which is also a perpendicular distance of root 11 from pi 1. So in this case, we just go downwards. So that third parallel plane is going to be somewhere like this, pi 3, okay? And for that, we know that the line L will pass through pi 3. So we know that is given by the equation R equals 2 plus lambda, 1 by 2 plus 3 lambda, and 1 minus lambda. Okay? Again, the equation of the plane will be the same. However, it's going to be given by the offset value right here. This minus 17 or 5 from pi 1 will be different. So we know it's going to be something like 2 plus lambda plus 6. Or actually, we can directly simplify this right here. We know it's 5 plus 22 lambda is equal to q. All right, and the other thing we know is that the distance is going to be root 11. So actually, we can just compare the difference in lambda here. So for this one, at pi 1, or point A, the lambda value was 0, okay? At pi 2, this is a linear parameter, so if we move a distance of root 11 in space, we're going to move by the same amount in lambda on line. So we know that A and B was given by lambda equals -1. So pi 3 must be given by lambda equals 1 because we're moving in the opposite direction, the same distance. So we know that 5 plus 22 equals q. So q must be equal to 27. So we get the final equation 2x plus 6y minus 2z, I believe, is equal to 27. And this is our equation for pi 3, the plane which is root 11 away from pi 1 in the opposite direction.